We're at chapter 14, lesson 7, and for those at home, we are skipping over lessons 5 and 6 because they involve having a protractor and measuring, and I can't supply you with a protractor, so we're going to have to skip over those lessons, and I'll make sure I modify the test. Does it disinclude any questions that involve measuring that? You can look up some videos if you want to try those lessons for your own learning. I'm sure they have several that you can look up on YouTube, and you can email me and I can give you some links. Otherwise, we're going to move ahead. Lesson 7, solve problems with angles. An angle can be decomposed or broken into non-overlapping parts. The angle measure is the sum of the angle measures of the parts. So just like if I were to take the circle that I've drawn here, and remember we talked about this is 90 degrees, and the whole thing, the whole circle is 360 degrees. So if I took this and did 90 plus 90 plus 90 plus 90, I would get my full 360. So that is what it's saying when it says the angle measure of the whole is the sum of the angle measures of the parts. So the 360, the measure of the whole, is the sum of the angle measures of the parts. That's what that's saying. Okay. Example 1. Rachel and Dean made a sign out of fabric like the one shown, which is blocked by my camera. There you go. To hang in the school gymnasium. The blue piece has a 35-degree angle. The red piece is attached to the longest side of the blue piece. Together, the pieces form a right angle. What is the angle shown on the red piece? Okay, so we know this is a right angle here. We're looking right here and right there. And we know that the blue piece, this section here, is a 35-degree angle. And we know that this whole shape is a 90-degree angle. Let me point. 90 degrees. So now we need to figure out what the angle in this red is. That's what it's asking us. So if we know the whole angle, all of this from here down to there is 90, and we know this piece is 35, we can figure out the red piece. And we'll draw off a 90-degree angle like it's shown here. 35 is the blue. We need to find the part of the red. The protractor to measure it, but since we don't have that, we're going to have to do it the equation way. 5, the unknown, they labeled it R, is 90. So you know that 90 minus 35 equals R, because addition and subtraction are opposite operations. So we've got 90 minus 35, and that's going to give you your product there. So looking at examples, you're going to have to read what measure of the full angle by the number tells you in the picture, or the figure, the measurement of one of the two that it's decomposed into. So this is an angle that's decomposed into a 75, and then you have to find what n is by taking the difference between 90 and 75. And difference tells you what kind of problem? That would be a subtraction equation. And here it tells you the combined angle, so this larger angle here is 130. You're going to subtract 35 from that to get k. So hopefully that makes it small, and you need to not subtract 2 decomposed, so you need to find the full angle of the two parts. So you're going to do a different operation there. Hopefully you see what the operation that is by looking at the picture or thinking about it. So that'll get you through page 912. And the directions I gave you will also get you to top 30. It's the same thing. You're given the whole, and then you need to find the missing the missing part of the decomposed angles. So that'll help with the top there. It does do something different down here. You have to draw a right angle, and then once you draw that, you make it into a triangle. So just connect the other two, the ends that normally would be the arrowed ends of the ray. You would just connect them with another line. Do the same thing with an obtuse angle. And then because you don't have a protractor, you will not be able to do this. So I'm just going to go ahead and have to tell you, because unless you have a protractor at home and can use that, you're not going to be able to measure those. But anytime you draw a triangle and you find the measurement of all three of those inside angles, they will all add up to be 180 degrees. I don't see a degree symbol. But every time a triangle, all the interior angles will be 180 degrees. And that is going to come in handy as you continue forward with geometry. The same kinds of things in different ways. So they're telling you here that this angle is 90 degrees. There should be. And it says here the angle, one of the steps is crooked, so you can see that illustration there. It's definitely an obtuse angle. And it's saying here the angle formed is 15 degrees too large. So if 90 degrees is how it would be, and this one is 15 degrees too large, that means it's 15 degrees larger than 90, which hopefully will get the operation you need to do in order to solve that. And this one is like all the other ones. You have the whole angle. The measure of all of them is 150, and then one of the angles over here is 50 degrees. So what is x? If the whole thing is 150 and this 150, what measurement for x? And you can do that without a protractor, just an operation. Okay, again here, if we've got a 90 degree here, and this angle is twice this angle, then you can divide it into 3. This will be 1, and that will be 2 of them, if that makes sense. So take your 90 degree angle, divide it in 3 parts. One of those 3 parts will be this one, and then 2 of those 3 parts will be this here, and that'll give you the measure of this and that angle. It'll also give you what k is, which is this smaller angle. How is addition related to angle measurement? Well, because when we have the whole, we can use addition to figure out the parts. Well, we'd have to use subtraction to figure out one of the parts, but we could have, if we had the 2 parts, we could figure out the whole by adding them up together. So that'll help you through the lesson, and if you still have time, make sure you're looking and doing the homework. Refer back to these problems and watch the video again if you need extra help on that. Thanks. Keep working hard.